All right, and we're live. Welcome back, everyone. Welcome back to another episode of Today's Weather Tonight. Here, as always, I am your comedian slash meteorologist, Cloud Hudson. And here's today's top weather stories. Forecast got it wrong in Western North Carolina. My forecast was right. I expected that we would be getting snow today, and we are. Many people tried to tell me that their weather apps said there wasn't going to be any snow, that it was just going to be cold. I don't know how many times I have to tell people that I'm right before they'll believe me. Probably till the day I die, I will have to convince people that I am a real meteorologist and I know what I'm talking about. Until then, people are just going to point to their phones and be like, it says something else. Listen to real live human meteorologists. Let's talk about it, okay? Shall we? Let's dig into this. I'm certain that the forecast was revised because it looked like there wasn't as much it looked like there wasn't going to be as much of a moisture convergence over the southeast as was originally thought. But they also got it wrong last weekend when they thought there would be a lot more snow because people who don't live in the mountains forget to forecast for the mountains. What's happening here is, in my opinion, resembles a northwest flow snow event. What is that, you say? Well, I'm going to get to it in the weather update. But for right now, all you need to know is that winds are coming from the northwest. And this is in the wake of a front. Here's the front out here. This is the low. This is the storm system. So you think, the storm system's not really over me. How could it affect me? Because of the northwest flow snow event effect. Temperatures right now are frigid and dropping. We've got, I don't know why that clicked up there. We're in the 20s and like teens in much of Western North Carolina. I like the resolution of this map, but it's not my favorite resource. Let's go to our headlines. Heavy snow forecast. This website did get a pretty good forecast. It said slight chance of snow showers after 5 p.m. I'd say the snow started at 4. Actually, the snow started flurrying around like noon, 10 a.m., something like that. Chance of precipitation, 30%. Little or no snow accumulation is expected. Bullshit. Snow accumulation is likely. It is already happening. Sunday night, isolated snow showers before 9 p.m., mostly cloudy. Wind chill values as low as -5. Chance of precipitation, 20%. Also bullshit. It is 100% chance of precipitation is happening right now. Sunny with a high near 21, wind chill values as low as -10, so that sun won't help melt any of the precipitation. Looks like we don't really have a chance to get above freezing until Thursday. So, yeah, everybody in my area, just be advised that the forecasts right now are very they're way underestimating the snow potential of this storm. On the complete other end of the spectrum of things, Kilauea is a hot volcano. Snow is happening from the cold sky over here, and over there there's hot earth being blasted up from below. Lava fountaining is beautiful and happening on Kilauea right now. Let me go look up in a different tab while you guys can watch that fountaining. I'll pull up our volcano headlines and I can read those while you get to watch. Oh, it's not letting me do that. There we go. There we go. So Sakurajima and exploded. Kenlone had an eruption. Mount Ibu had volcanic ash explosive activity. Explosive activity continued at Ducono and Santo Aguito and Songhai. And Reventador in Ecuador had new volcanic ash emissions. Let's see. All those same players had that activity yesterday. Throughout the day, continuous volcanic ash emissions from Popo. We're seeing new volcanic ash emissions from Nevado del Ruiz in Colombia. Yeah, and no other updates on Kilauea. Let's see. Yeah, the last update we have is from the 16th. Small sluggish lava flow from the north vent signaled a start of the 4th episode of the ongoing summit eruption. So that's what's going on with Kilauea. As you can see from the video I'm showing you right now, beautiful fountaining, 2 spatter cones, 2 lava cones. So this is where the uplift occurred, and now there is deflation, obviously, because this is letting off the pressure of the magma below the surface. When the lava surfaces, it can, man, look at how beautiful that big trail of lava flow is. I love seeing the big ooze creeping along. Looks like you might have those ropey lines of Pahoehoe lava flow. I'm no volcanologist, so I'm not really well versed in the different types of lava flow, but I know that one is one where it's like resembles ripply liquid water kind of flow. All of this grayish area right here, this is all the skin, the crust forming on top of molten lava that's below it. So it's kind of like slab flowing, sheet flowing underneath this crusty top. And the crusty top, you can see, gets continually pushed forward by the lava, like it being emitted from these 2 lava fountains here. Now it looks like there's one trying to form over here as well. Like maybe there's a lava flow there. Beautiful stuff. And these are spatter cones that are building up around the side of the fountains. The spatter cones are just what they sound like. They are cones made out of the cooling spatter of the lava flow. Okay, earthquakes. Let's not forget to do earthquakes. All right. Let's see. Anybody here? Not yet. Let's look at our earthquakes. Okay, so currently looking at, I had to creep it forward just a little bit. Okay, there we go. 3.0 out here in Wyoming. We had that was at 0 kilometers depth. That's surface 3. We had a 2.3 in the middle of Oklahoma. There were several 1 to 2 magnitude quakes in both western Texas and near west central Texas, I'm going to call it. Let's take the ring sizes down, and we can see that there is a 3 in here somewhere. Where did I see that? There's 2 and a 2.4 up here on the other side. Death Valley. Let's see. Oh, here's the 3. Right here on the Baja Peninsula at the end of, which river is this? I forget. That's at 4 kilometers depth. Then a smattering of earthquakes all throughout Southern California, ranging in the 1 to 2 range. We got a 3.3 and a 2.3 and a 2.1 out here in the Juan de Fuca fracture zone. Zooming out again. This one looks deeper. It says, but it's only 19 kilometers depth. No, that's the 1.5. That is at 16 kilometers depth still. Oh, that looks fairly large. Why do those ring sizes look so big? It looks like they're just 2s. 2.5, 2.3. Hello, doctor. Welcome to the show. I'm glad you made it. We got some deep earthquakes happening up in Alaska. Okay. Really quiet over here in Japan, Russia, that area, pretty chill. We had a 4.4 at 93 kilometers depth here in the central Philippines, a 4.6 here, actually truly in the heart of the Philippines, and a 4.6 down here, kind of all in a row, equidistant spacing from each other, just kind of a ripple effect. But they go in order of blue was first, then the purplish color was second, and then this was third. So it's kind of like it went back and bounced that direction. 4.5 over here in Papua New Guinea. We had at 122 kilometers depth. There was a 4.9 at 196 kilometers depth, also in Papua New Guinea. Just north of New Zealand, we had a 4.5 at 82 kilometers depth. Nothing down there in Antarctica. We had a 4.7 in central China. I think that's not the Yangtze River, is it? I don't remember which river that is. It's near a bend in which river in China? The Huanghe, closer to Baihe rivers there in China, just really right in the middle of it, right in the middle, smack dab in the middle of the country. Hello. The 4.5 we had over here was in the part of Tibet that we've seen mid-range 5s and 4s from ever since it had that 7.2 a couple weeks ago. There's a 4.2 up here at 152 kilometers depth. This is just on the Tajikistan side of the border between Tajikistan and Afghanistan, at 152 kilometers depth. We had a 4.4 reported at 10 kilometers depth. That's just kind of the remote sensing depth approximated, in Ethiopia, where we've got active volcanic conditions in the Great African Rift Valley. Down here in South America, we had a 4.4 at 98 kilometers depth and a 4.7 at 109 kilometers depth down in Argentina. So let's move on from our earthquakes to talk about our atmosphere, because boy, oh boy, do we have quite the, oh God, we got quite a bit to talk about. Let's see. I'm going to try to split screen. Can I do like an even split between this and Yeah. Let's see. Okay, so I'm going to try to talk about a northwest flow snow event here. While, okay, so if you're wondering why I'm talking about this, it's because it's very relevant to my local weather. And I also just experienced some pretty treacherous conditions on the roads getting back to my house today. It was crazy. People were jackknifed all over the road, and the freezing set in very rapidly. There was already a really well saturated ground, and let's wait, hold on. There was already really well saturated ground surface, and then the freezing temperatures set in. We actually have been seeing flurries of snow in the area all day since, like, I think between somewhere around noon, 2 o'clock. Was it? I would say between noon and 2 o'clock, we started seeing flurries in my area, which is near the Asheville area of North Carolina. The reason that we're experiencing this is, in my opinion, what looks like the weather pattern that looks like it took over in the region around 2 o'clock today is a northwest flow snow event in Western North Carolina. So this is a nice little summary of it put together by the Greenville-Spartanburg National Weather Service office. I don't know why they could put together this and didn't see it coming, but I'll forgive them for now. Welcome Michigan and Vermont. I hope that y'all are enjoying your snow as well. We're going to talk. I know some people in Oriental North Carolina, the Eastern North Carolina. That is a funny way to say it. Okay, let's talk about what's happening here. I can't. Let me move this over here. Okay. Northwest flow snow. Snowfall in Western North Carolina occurring during periods of low-level upslope flow across the southern Appalachians. That means moving from here to here. Winds in that direction. Winds going like this. That is upslope because it goes from a lower elevation up the slope to a higher elevation. Yeah. So this is what it looks like from the perspective of, like, horizontally. If you could slice through the mountains, this is what it would look like. This is why we get orographic lift. We talked about this a lot when Hurricane Helene hit. I talked about what orographic lift is and how it occurs, the physical forcings. Basically, mountains both eat up rainfall and produce rainfall. They'll get the air parcel to rise, condense into water droplets, precipitation, and then drop them out of there, and then the air parcel will move past the mountains, a drier air parcel for having undergone that process. Here's the kind of snowfall distribution that we see in a northwest flow snow event. We'll start to see things up here near Banner Elk, and also here in, that's right up there, also here in the Great Smoky Mountains National Park, as our first areas of accumulation. Now, when I go back to show us where we've been getting our snow today, what do you know? It's almost like that. It is definitely snowing between Gatlinburg and the Great Smoky Mountains National Park. Definitely getting a lot of accumulation there, according to this particular winter weather radar. I'll talk about why different products are showing different snowfall in a minute. Looks a little dry up here, but that is only because the radar is not sensing the actual snow. When we go to reflectivity, it looks even less like something would be happening. These look like nothing clouds right now. But again, like I've talked about in the past few weeks on this show of winter weather, when you see freezing temperatures, when you see frozen precipitation, what could just look like a cloud on the reflectivity radar might actually indicate flurries or snow. That is certainly the case here in Asheville, because we are already seeing accumulation outside, and it hasn't even looked like any precipitation fell in the area according to radar. Let's look, but radar can be deceiving, especially in valleys and mountain areas. Let's look at our lower level water vapor, because that is where we're going to see a little shortwave trough embedded in the lower level water vapor imagery. At first, in the beginning part of the day when we weren't getting precipitation here, you'll see that the flow was actually from the southwest to the northeast. That's when this front out here was passing through. Out ahead of the front, where the warm front is, we had that movement from the Gulf up towards the northeast. You see, most of the day we're getting very dry air because we're getting the wake of this front or this dry line. It's really once this trough starts to dominate the flow that we start to see the northwest flow snow event type of clouds forming. You can see these are northwesterly dominated because of the direction of their streaking. You can see this big pool of cold air hitting the southern Appalachians and pooling out right on the other side, the windward side of the mountain. So we're around 11 a.m., 12 a.m., and around 2 p.m., we start shifting from southwest flow to northwest flow. And you can tell that by the orientation of the wake ripples that are flowing off the top of the mountains there, and the direction of the plumes of water vapor. See, we go from clearly it would only be snowing up here in Kentucky to, oh my gosh, it looks like we are setting up some sheep in the pasture type clouds above the southern Appalachians. It's really around tonight, around between 5 and 8, that we got this big burst of cold air, and the dry air won't be coming in for another few hours. We're getting some of this moist air that in all likelihood probably came from the lake effect snow, which is one thing that northwest flow snow events get their moisture from. They get multiple moisture sources. So there is first of all, look at this way back here. We've got a little bit of looks like a streak of moisture there. We've got this whole big trough, whole big trough swinging across the United States, and then changing its axial orientate, like changing its tilt as it gets to the Appalachians. You see the lake effect snow here. You see it here as an increase in moisture as it goes across those Great Lakes. You can see the water vapor is increasing. This would be in an orientation like orthogonal to this gradient, like at a right angle to this dry to wet gradient right here in the lake. You also see the same direction of winds here. They're not exactly blowing towards, like, the air mass I'm experiencing didn't come from right over here, but it is supporting an atmosphere where more water vapor can move more easily in this direction. The water vapor here is really coming up here from Minnesota. Kind of this whole high circulation right here is, I mean, you even see it coming off the Ohio River, I think. Let's watch this again and watch some of this streaking in the Ohio River Valley contribute to, it looks like, some positive generation of water vapor in the area. Once we switch to that orientation of wind, looks like over the fields, the croplands in southern Indiana and Indianapolis, these almost mountainous southern lands here of those two states, contributing to some generation of water vapor. Beautiful, scary, definitely happening. I don't know how else to put it. There's also a back entrance flow of moisture here. We're not just getting the moisture that was associated with this front or even this trough. We're also getting new flow in across, like, Kansas and Oklahoma that's about to sweep across Arkansas through Tennessee. Let's look at this at the mid-levels, and you'll see what I mean. How this mass over here, this is, let's call this green. This mass of moisture over here is going to move that direction. Oh, that's a terrible. Going to move that way. And the dominant winds at the lower level, so let's call that lower level dominant winds, they're going this way. So the upper level where we feed the clouds is getting a nice source of water vapor. The lower level where orographic lift takes place is in the right orientation to maximize snowfall for Western North Carolina. And we are moving into seeing the results of that play out. There's multiple sources of moisture, both the wake of the passing front and the, like, ebbing, the flowing in of a new storm system back here. And this, again, is at the mid-levels. So this is like 850 to 500 millibar kind of levels. And we're seeing that orientation creating the ripples that show us the direction of the flow again, because these ripples form in, like, right angles to the mountains. They flow in right angles to the wind flow. So when you see these, let's see. Oh, it won't let me pause on something like that. Okay. Let's go to like 75 frames. Is it going to show me ripples? Yeah. When you see these ripples in like dry, moist that lamination, that is showing you that the wind is blowing perpendicular to that, because these ripples form in the wake of the leeward side of the wind, or leeward side of the mountain. Up at the upper levels, we are fully supporting the continued growth of this precipitation. The higher up in the atmosphere you go, the more supportive it is. We've got this upper level jet of moisture streaking right across. That is actually coming from the southwest, but it's the lower level that we care about there being northwest flow from. The misalignment of the orientation of winds too, like the winds going from northwest to southwest sources, as it increases with height, that's a cold air advection happening. We've got, let's see. Let's talk about single site radar, because this picture of a comparison to the, and I haven't checked. I hope that you appreciate this. Thank you so much. So let's see. The Morristown, Jefferson City radar site in Tennessee is the one that's going to be most helpful for us, even though both this one and the Greenville-Spartanburg radars are blocked by our mountains to see where I am. So we see a dominant flow of this way, all until like 10 a.m. And then at noon, we swing towards getting that northwestern flow. And everything starts to become frozen precipitation, whereas it was rain before. This dominates the action. You see the streaking going. All right, see, we've got pretty much just higher elevation moisture, keeping going. And then all of a sudden, switch. We switch right around between noon and 1 p.m. We switch to a northwesterly dominated wind flow, which I don't know if you can tell, the shape of where precipitation is happening right here matches very well to this. I'm going to try to show this right here. Can I get this to show a little better? This Northwest Flow snow event example, we've got like, it doesn't exactly track because up near Banner Elk is missing its portion of this, but assuming that just a slight change in the degree of the wind angle can really change where the maximum snowfall happens, it makes sense that right around like just north of Mars Hill, that's actually Hot Springs, North Carolina, and right here, High Rock, Lick Rock, Rice Bend, Little Creek, this little bit of dip in the this dip right here is getting a lot of precipitation. And then of course, our Great Smoky Mountains National Park, from Sevierville to the Smokies, from Sevierville to Cherokee, we are getting a lot of snow. And we're also getting a lot of snow right through this little cut here, kind of like parallel to 40 as it approaches Crabtree Bald, Big Butt Mountain, that is the name of it, Sandy Mush Bald, this area, we see several little pockets of way heightened snowfall compared to the other areas that may not be getting anything, like right here. The angle of the wind is such that it's not really blowing through that notch of safety. Sometimes we get winds that come right in through Hot Springs, through across the French Broad into Marshall, into Asheville. That's when we would get the most snow here in Asheville, but it's just barely been blocked by some taller mountains over on the other side. Like the precipitation that would have fallen here fell up here. You can kind of see where there's a lack of precipitation downwind, there is an abundance of precipitation upwind. So like on this side of Jefferson City, there's a lot more snow. That means that it ran out of gas, and this little streak is going to have drier air going over it. And then where we have an abundance of precipitation downwind, we saw that upwind, there's a lack of precipitation, meaning that it didn't really experience its uplift from the mountains until it got around here. And this is Green Mountain. This is a pretty high area. 3 of the highest peaks are around this area. Three of the highest peaks on this side of the Mississippi are. And notice how the areas that are getting precipitation vary a lot. They change a lot when the direction of the wind changes. Just slight degree changes in the direction of the wind will affect where the bands of precipitation are. So right now we're experiencing, there were some that slipped through. Right now we're experiencing a lot more. Let's look at like 100 frames loop. So we just look at the snow event. Yeah, as we churn over to snow, definitely this streak from like I-40 Newport to Waynesville to Brevard and Hendersonville, that's getting a lot of snow. Just north of Mars Hill is getting a lot of snow. The highest elevations definitely are, but I can vouch for everyone in the Asheville area when I tell you that it is definitely snowing here. There's definitely high winds, and it is very cold. And the snow is sticking, and the roads are icing. I don't know how to prove that to you meteorologically from the radar products we're given. I think Tilt 2 might give the best glimpse. This radar station produces 4 different tilts. Every radar station produces a different type of products based on what's relevant to invest their infrastructure money into. But this one gives 4 tilts, so it gets different angles of attack of getting the reflectivity of droplets in the atmosphere. I think that for the Jefferson City, Morristown radar, looking at Asheville and the valley here, the French Broad River Valley, Tilt 2 is the best one to get a little bit more of an accurate reading on precipitation above us. And you can see, I don't think the precipitation just evaporates when we get to this edge ring of it. I think this is just in the scope of diminishing returns, because you can see kind of a perimeter of where this really, really fine return signal is getting filtered out by noise filtering. You really do need a stronger reflectivity signal for it to be able to bounce all the way to Asheville and back. So that is why this radar doesn't pick up on a lot of the little tiny flurries that happen in Asheville. Like I said, it's been flurrying here since like before 2 o'clock p.m. today. And that was just like little teeny tiny flakes floating around, doing twirls and stuff, going up vertical in the atmosphere, just really light dusting. And then it's turned into a heavier snow that's just persisted all night. Let's look at Vermont now. I want to see, actually, the Albany radar is going to be better. You guys are dealing with a very different type of snow. You're still getting flow from the southwest. You're also getting overlapping zones. You can kind of see the snow orientation doing like this. You can see bands of snow waving in and out. There's two different wind flows competing for dominance here above Albany. Let's look at our winter weather radar there. Seeing a lot of accumulation, or a lot of snowfall here. I bet you're getting a lot of accumulation. I'd be really curious to know if you've gone out and measured your snow and how much you've gotten, because this looks like a healthy helping, a decent amount. And you were under a mesoscale discussion earlier. Let's look at the radar here in Maine, where there's a mesoscale discussion for heavy snow. This is the radar here in Portland, Maine. That's where the actual center of circulation low is right now, is just off in the Gulf of Maine. Heavy snow. So let's see. Heavy snowfall with rates at or exceeding 1 inch per hour are expected across coastal Maine through 9Z as a surface cyclone tracks northeastward off the coast of New England. A rapidly deepening surface low tracks northeastward off the coast of New England. Strong isentropic ascent and lift in the dendritic growth zone will result in heavy snowfall across portions of coastal Maine. Strong isentropic ascent means moving along the isentropes to lift the parcel of air. Isentropes are lines of constant entropy, which sounds like lines of constant chaos, and it kind of is, but it really, entropy is more than that as a variable in the atmosphere. Kind of shows you, like, all other variables aside, what's the, it's like the vibe of a parcel. What's the vibe? What's the max? Things can move along lines of constant entropy very easily, meaning it's easy for an air parcel to get lift, aka the ascent needed to precipitate. It's easy to get that as we're moving along lines of constant entropy. So isentropic ascent and lift in the dendritic growth zone. So that is lift in the area of the atmosphere that is in the right temperature and moisture levels to create snowflakes, result in heavy snowfall. Surface pressure falls in recent obs have increased confidence that some areas on the coast could meet or exceed the 1 inch per hour snowfall rates. Low visibility is expected. So this is definitely happening up here. Getting some pretty scary amounts of snow up there in Maine. Now, where else are we looking? Michigan. Well, depending on what area of Michigan they're in, they're either getting lake effect snow, or just like a scattering of like a hangover of like lake effect snow. See here, just north of Detroit, they're not getting a whole lot because they're in the way that the winds are oriented now. There's a whole lot of land to the northwest of where the wind blows over. It blows over way more land before it gets to this radar station than it would, for example, near Grand Rapids, where this just came off the lake. The air mass just got reinfused with moisture. Or up here, where we have the same situation. It just got 2 different lakes of moisture to reinfuse the atmosphere with precipitation ready moisture. You can see that no matter which orientation it's coming from, this area is definitely getting dumped on. Looking at the big radar again, you can see that many of these places, while New England looks the worst right now and is definitely getting the worst of the snow, I think places that weren't warned sufficiently are going to see some damage as well, which means the Southern Appalachians, people were not expecting a northwest flow snow event, which is what I think we're experiencing, in my opinion. I do want to go back to those slides, show you, this is kind of the waveform of precipitation, Asheville, adjacent northwest flow snow events. This is actual data from December 18th through 20th of 2003. Primary characteristics: forced by orography, which we can clearly see in our radar out of Tennessee. We're seeing that the higher elevations are where the snow is jumping off of. It's not one big squall of snow coming in. Often not associated with extratropical cyclone precipitation shield. The precipitation shield is what's going on up here in the northeast. Synoptic scale environment can be dominated by forcing promoting downward motion. I haven't looked at those forcings yet. Occasionally, troughs embedded in northwest flow enhance snowfall. So I think there is an embedded lower level trough, shortwave trough. Snowfall distribution quite irregular and highly variable accumulations, sometimes only flurries, sometimes warnings. I definitely saw that today, just in time throughout different spaces. Post-frontal is the situation we're dealing with. We're in the category of post-frontal, a classical northwest flow snow event in Western North Carolina. Strong winds, blowing and drifting. That's been going on since 2 p.m. today. And it's not the comma head or the cutoff low. We don't have a cutoff low in place necessarily right now. We don't have the classic extratropical cyclone comma head shape, that mid-latitude cyclone shape, which would be the wraparound, which is that backwash, backflow I was talking about. It would be the comma head if this bit right here, let's do what color you can see. If this bit of the comma head were wrapping back around, I mean, it is wrapping back around here, but if it moved all the way back here to wrap around, that would be more like the comma head thing that they're talking about. This, I would say, is not as much associated with the comma head as much as it's associated with being in the wake of like the post frontal zone. It's post these fronts. Let's make sure that I can't get the zoom right to not have, okay, there we go. That's a pretty good examination there. Let's do this up just a little bit. Then post-frontal does not look like what we've got going on right here, right now. A big old cold front draped off the East Coast and a huge low pressure system centered around Massachusetts that is almost exactly the same setup that we have right now. There is a high keeping this trough very low in keeping this polar vortex pulled very low here. There is a low coming in on the backside of that high. Postfrontal shows that it's sagging down above the Midwest, and that flow goes from here to here, that northwest flow. Also, we see the wake eddies, not wake eddies, the ripples, like the sand desert dune ripples that I've been talking about the whole time. We see streaking before the mountains, indicating the direction of the wind, the direction of wind flow going this direction. See, going that direction. We see these little, I'm going to make this a little smaller now that I've zoomed in. Let's go to, all right. You see the wind direction is this way because we see the little dots of clouds. And we see right here, these ripples, these little ripples, the dunes of clouds kind of creating parallel lines in the wake of skipping over and being sent to bounce up and down like skipping a stone over the surface of a pond. The air parcel kind of goes boom, 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 boom across the sky in the wake of tipping up and over the mountain. And that's exactly what we've been seeing over here in our actual water vapor imagery. Satellite imagery, I'm sure, would show the same thing. Let's see. I'm going to take this off now and go back out. This is what it actually looked like at Purchase Knob in Haywood County for this storm. Yeah, I mean, it looks very, very similar. Let me go to, let's see if our visible satellite in 250 frames would be good enough. Oh, it doesn't want to give me good satellite imagery for our visible. Oh, there we go, because it's not sunrise yet. There we go. So here's our visible band, and we see it in the wake of the mountains, very dry. Then sunsets. But let's look at geocolor. That might help. You're going to see some definite similarities between the examples given in the National Weather Service's PowerPoint here and the actual observed satellite imagery from today. So remember, we started out with a southeasterly dominance in the flow, and then right around noon, we turn and get that northwestern flow going. You see that happen? Where we're dominated now by northwesterly winds coming all the way across, just perpendicular to the slope of the Appalachian Mountains. And I think that is what makes northwest flow events so impactful, is that they are perpendicular to like the slope of the grouping of mountains itself. So that everything is hitting the face of the mountains at the steepest descent rate possible. This is like, instead of walking along the side of the mountain to get up and doing switchbacks so that it's an easy gradient, this is the air hitting straight up, just trying to climb straight up the face of the mountain instead of like gently scooting along its side to get to the top easily. That's what creates such rapid snowfall. yeah, I don't know what else to say. Don't know who I'm convincing, but this is exactly what our base reflectivity out of Morristown looks like. We were just looking at that. Yeah. Horizontal and vertical extent of post-frontal moisture. Flurries and snow showers west of the mountains. Temperature, stability, wind direction, and wind speed, and upwind short waves embedded in northwest flow. That means there's that micro trough embedded in the northwest flow event. It's really cold. Temperatures have well set in so that moisture is the limiting factor on precipitation here. Clouds should extend to 15 degrees C for most efficient generation. This is optimum dendritic generation. Infrared satellite on the Nikaya curve. One of several moisture sources. There are moisture sources coming from the Great Lakes. In our case, there's a moisture source coming from both the Great Lakes and the air that is sweeping down across the Rockies, and a little bit what is coming from the Pacific across Mexico into the Gulf of Mexico. We've got several types of moisture feeding this area. And you can see there's different orientations of the wind flow at different levels. So all of them are aligning to push the moisture here. Now let's see. This just goes into which model guidance is best for this. And yeah, let's go to, I want to see, I want to see my multi-layer. I want to see this. Derived motion winds from GOES. 6 inches. Oh my goodness, you've got 6 inches. Michigan here. Hi, Michigan. Welcome. Wow. Welcome aboard the train. You're in northwestern Wisconsin at the moment. Okay. 6 inches. -10 degrees Fahrenheit when you're in Wisconsin. It's too cold to snow. That is true. At the moment, you are at like a point where the atmosphere is so cold that it just can't hold the moisture enough to support dendritic growth. Gotta catch up on Smot Show. I don't know what that is, but thanks for being here. If you're just tuning in, I believe that forecasters overlooked the possible effect of northwest flow on the snowfall totals in the southern Appalachians today. Upper levels, you can definitely see that the upper levels are dominated by a southwest to northeast flow. That is supporting the more classical cyclone winter storm that's occurring in New England. But here in the southern Appalachians, I mean, well into Alabama and Georgia down here, we're getting a lot of mid-level and lower level winds, really the low-level winds. The mid-level winds are kind of diverging above this. The low-level winds are bringing moisture from way back here in the Rockies and way up here in the Great Lakes to the area that is kind of married with this upper level jet stream. Winds are going counterclockwise with height. They're going backwards. We're bringing in a lot of cold air as well as that moisture. And this is resulting in a type of snowfall pattern that I think is it resembles a northwest flow snow event. I said this a couple days ago when the models were about a week out. I said it looks like we may be experiencing the right setup for this, where in a post frontal, so meaning that the main front that produced this big winter storm for the Northeast has already gone through. We're getting northwesterly flow in the kind of like the backflow after the trough has already passed this area. That's what happened today around between noon and 2 p.m., where we went from southwest to northeast winds to northwest to southeast winds. That was the trough moving through the area. And once that trough moved through the area, we have a dominance of northwest flow. We even see it up here. It's not really modeled very well by the arrow approximations, but it starts all the way up here in the Dakotas. Let's go to look at pivotal weather. I really think that the National Weather Service severely underestimated the severity of the snowfall event happening here in the South. I mean, they do have tons of freeze warnings and watches, winter weather advisories, winter storm watches and warnings in effect. But like where I am is only under a winter weather advisory, and I witnessed multiple car crashes on my way home. I don't want to scare anyone, but like it's bad. It's not awesome out there. The road conditions are such that we had a lot of water deeply saturating the top levels of both the pavement and the raw ground. We've been getting rain over the past few days. Everything's set up to have a lot of moisture there. And it's been cold enough that while that moisture hasn't frozen, it is very much on the verge of freezing. So once the sun set today and we got those steady, cold, icy winds and more snow, more like ice nucleation sources, the roads started freezing over slick really fast. Black ice, the real definition of black ice, where a black road that just looks like it would be wet is actually solid ice, has turned to, complete shit. I'm glad you can stay home. That is not an option for everyone, but I hope it is. Let's see. Oh my gosh. We also forgot to talk about the California wildfires today. While there is a freeze watch just north of them, there are more red flag warnings in Southern California right now, in addition to wind watches, high wind watches. You can see how disconnected the snow winter weather threat is. Winter storm warning all the way through Texas and Louisiana. The North Carolina, Tennessee border region, West Virginia, and Eastern Kentucky, and the coastal New England. Wisconsin, you're way too cold to snow. Let's see. Let's look at our forecasts, our models actually, so I can get a sounding. I don't want to, let's see. Our 0Z is just starting to load for the euro. Let's go to the GFS. Let's see. What is it looking like in What's the sounding like in southern Vermont? Yeah, look at that. You have at the surface that the optimum dendritic growth zone is 12 to 15 degrees Fahrenheit below freezing, or below zero. I'm sorry, not freezing. 12 to 15 degrees below zero Fahrenheit is the optimal snow growth. You've got clouds with a generous layer in that sweet spot for snow development. And then at the upper levels there, or really the mid levels, you're still staying a saturated cloud well into the mid levels. That is healthy snowstorm growth. Let's see. Down here in the mountains, it looks like it shouldn't be moist enough to precipitate. However, I believe that this is probably an overestimation of how warm it is or how warm it's going to be, and an underestimation of how humid it is. Definitely doesn't look like it should be snowing, right? Well, it is. That's why they don't have it shaded as snow, because GFS doesn't think it should be snowing. It is, in fact, snowing. That's our 6-hour precipitation accumulation, 24-hour, 72-hour. Oh, I never moved this back onto the screen. Sorry, guys. And then in our 1 week, this is our accumulation totals. Let's look at our observed snowfall. Looking at really high totals here in West Virginia right now. In the past day, over the past 48 hours, and over the past 72 hours, that's what we're looking at. Seasonal snowfall analysis, we are getting up there. Everybody's looking like they had a really healthy snowfall season, and we're not even done. Okay, I want to move on. Yeah, that sounds beautiful. I'm going to try to take videos of what I'm seeing here too. Let's go back to just cruising through. Let's take a look at our Schumann resonances lately. I feel like there was a shift in our geomagnetic conditions where we're no longer undergoing like active geomagnetic conditions. We did have a little bit of an increase in the Schumann resonances yesterday into today, but nothing too major. We're just back up to moderate Schumann resonance activity. And the magnetosphere movies. Let's see. Beautiful. Oh, look at that big burst. We got quite a big burst in velocity here. Beautiful. Looks like there's a backflow bubble all the way around the Earth. Really interesting there. Let's see what that looked like in density. We can see these multiple bursts. Yeah. Beautiful. And a lot of the density that's on the night side of the Earth is flowing back into the front of it. Wild, wild stuff. Beautiful flow setup. Perfect for keeping our Earth protected. I think this is why my car key fob works again. I think it doesn't work while we have active geomagnetic conditions. I think when our Earth is pretty well protected from solar weather, it works better. All right. Beautiful. Let's look at our solar weather. Solar wind speed is moderately high, and interplanetary magnetic field is in the southward direction. Let's see, on the 18th, we had 7 coronal mass ejections, and then today we had 5. None of them look like they had a partial corona or a partial full halo, which would mean a component in the Earth direction. We are still at a KP of 4. Interesting. And climbing. KP index of 4. Coronal hole faces Earth. I bet this is going to... Oh, that's not... yeah, that is probably going to talk about that coronal hole that's facing Earth, creating lots of high solar wind. Looks like we peaked out in the mid 500 kilometers per second today. Magnetic field strength is moderately high. Density is low, but still variable. Let's look at our space weather dashboard here. 3961 is now a beta gamma delta type sunspot group, and that is the one right smack dab in the middle of Earth, facing us right there on the middle, almost right at the equator there. It's this group right here that's got this big arcing from one pole to the next. Looking really nasty, honestly. Probably could produce a coronal mass ejection that, if it went towards Earth, would be very bad. Let's check out our solar flares. Oh, we did have some M-class flares. I was expecting that, since, remember, on the 16th or on the 17th, I said, look at this. We had a high M. It looked like maybe we would increase again. Well, we didn't have much on the 18th at all. But then on the 19th again today, we've gotten back into peaking into M-class territory. We had an M2.4. But still, that M7 is the highest we've seen. Let's look at our imagery for this newly upgraded nasty sunspot that is just a big clusterfuck in the middle. We can probably see its magnetic shape growing, forming, spreading. Yeah, do you see it look like it's bubbling up from below? I think, okay, if you look around the perimeter of these 2 poles that look the most prominent, you can see that there appears to be an upwelling from underneath of the opposite magnetic orientation. They're kind of pulsating radially from these 2 poles with the opposite magnetic orientation. It's like bubbling, boiling water. It looks just like that type of flow. These are little, like, volcanoes of magnetic field. Let's see this in some nice 193 angstroms imagery. Let's coming from over here. This is like a minute and 45 of imagery. But you can really see the flow from each micronode within this sunspot region. Here we go. This is the big coronal hole that passed us. God, this is why I never click on the high cadence imagery. You can see it like arcing plasma that you would see between electrical nodes. I mean, that's literally what it is, but on a just ginormous scale. That's how I picture teleportation, like zooming from one magnetic pole to another. You can see the big arcs. That's where they're going. I mean, it looks relatively stable. Like, I don't see one succumbing to another. It's like they're arm wrestling. It looks really tight and stable. It doesn't look like it wants to give up a lot of its energy, which is unfortunate for fans of nasty solar weather. Let's go to our planetary weather. Oh, not that one. Planetary weather. By that, I mean the movement of the planets. The moon, or the sun, has just ingressed into Aquarius. So we are officially in Aquarius season. It's now the 20th. It's Aquarius season. Mercury is still in the second decan of Capricorn at 17 degrees, making an exact sextile to Venus in Pisces at 17 degrees, which just had its conjunction with Saturn. The day that TikTok got taken down and then given back was the Venus conjunction with Saturn in Pisces. I think that's fascinating because it was also in a rough square to Jupiter. Mercury is also in a rough trine to Uranus and Taurus. We've got, I don't know why they don't have it highlighted, but Neptune and Uranus are in a rough sextile as well. Uranus is also in a sextile aspect to Mars retrograde in Cancer. Mars retrograde in Cancer is squaring Black Moon Lilith. The nodes are back in Libra and Aries, just barely. The moon is at 12 degrees of Libra right now, opposing Chiron in Aries. We've got Mars opposing Sun conjunct Pluto in early Aquarius, so there is probably some foreshadowing for what's going to be going on during the age of Pluto in Aquarius going on right now. A little bit of the previews, the sneak peek. We're currently in a Sun day and a Mercury hour. We were just in a Venus hour. Sun opposite Mars is pretty prominent. Mercury sextile Venus, Venus conjunct Saturn. I said all these. Sun is at a Sun in sextile North Node. Sun should be sextile North Node right now. Yeah. Sun is sextile North Node. Yeah, and this Pluto-Sun conjunction opposite Mars is also happening trine Uranus. So, that's like an isosceles triangle between those. That's what's going on. Now, let's go back to Checking the vibes. It was kind of a crazy day for me. I got emergency supplies and was told not to go out, but I had to go out for the supplies, and on the way back, narrowly avoided a huge car crash. I don't know how I got through it other than my higher power, God, Jesus. I don't know. I have a lot of dreams where I'm about to crash my car and it's out of my control, and somehow I keep driving afterwards. And this was exactly like those dreams, only it happened in real life. I felt the same feelings I feel in those dreams where there's an impending car crash that I somehow survive. There was a car crash where multiple cars were blocking every lane of traffic. I couldn't swerve around it in the road with enough time. I applied the brakes, and I wasn't going a very high speed, but my brakes were locking up anyway. So I stopped applying the brakes, and I just cruised on through, aiming for the spot of least amount of damage that I thought I could get. And I threaded the needle between a light post and one of the cars in the crash by swerving up onto the sidewalk, and just like a full car width of room was between the light post and the car, and I just scooted on through. I don't know how. I have no idea how I got through that, other than higher power just like moving me like a little bubble. I drove onto the sidewalk, and I drove right off and just kept going and was fine. It was pretty crazy. So the vibes are weird out there. I don't know. I really don't know why meteorologists stopped calling for snow for the past couple days. Like yesterday and today, they weren't calling for snow in my area, and I'm just like, that is the stupidest forecast I've ever heard. Other than forecasts saying that the hurricane wasn't going to be that bad, this is the second stupidest forecast I've ever heard. Yeah, things are weird. Yes, somebody's definitely watching for me. That's for sure. Let's get a read on the vibes. Okay. Affirmations deck. Selenite. All right, what are the vibes for today? As I breathe deeply, I feel myself thrive. It's got a illustration of somebody in a field of flowers, it looks like. As I breathe deeply, I feel myself thrive. Thriving is as natural as breathing itself. By relaxing often and breathing deeply, your natural thriving is enhanced. Relax often and breathe deeply. Okay. Let's listen for the tarot now. This is the one I keep with the flashy little raw labradorite. There's its flash. There's its flash. Labradorescence. What goes with as I breathe deeply, I feel myself thrive. This is the vibe weather, the weather from the levels of the universe that are beyond the planets, beyond the scope of what we're currently observing in the material world as part of the daily transience of vibes, which is weather. The Tower reversed. Well, what did I just talk about? What's the story I literally just said? The Tower reversed. Near misses with fatal accidents. Something crazy bad going right for you somehow. I don't want to say like fortune from tragedy, but like definitely a clearing out of things that are in your way by the method of sudden disastrous occurrences. The Tower is a terrifying card to get upright. Reversed, it could mean an internal Tower moment, but it also could mean that you are having a mountaintop experience, that just taking a deep breath and thriving in every single moment is helping you get through traumatic experiences and grow from it, become wiser and more whole and yourself and a more resilient human being for having gone through it. Wow. What a card to draw today. I don't even know what to say about that. Now the liminal space. Got a pretty little ocean jasper with it. Postcards from the liminal space. What goes with the Tower reversed and as I breathe deeply, I feel myself thrive? Oh, jumped out. A magician is only as good as their tools. And it's got cool illustrations of like a scientist workshop type thing that's got money, a journal and pen, candles, books, an orb, a water pipe, some sort of smoking incense candle, crystals. It's also got a depiction of tarot cards themselves being with the magician. The magician card is depicted right there with the deck of cards. A hot glue gun, which is goes with the card trash magic, which we've drawn on here before. Prescriptions, an altar. We've got a lot of symbols of tools here. I don't know if I've ever drawn this card. It's really cool. Hell yeah, that's my card. I like that. A magician is only as good as their tools. The wheel was first used as a means of transportation around 3200 BC, and magic was alive and well long before that. Now there are cars, airplanes, rocket ships that can safely launch you into outer space. There is technology to connect us, infrastructure to support us, medication to balance us, more information available than ever before to educate us, as well as the practices of the ancients. Examine your resources and expand if necessary. What are you using and how is it working? There is no wisdom in refusing a tool that will help you. So, many tools available at all times. Wow. I got rid of my bongs, so I have almost everything. I had to smash them with a hammer so that I wouldn't use them again. That's me, mechanical. We do use all tools that we can on this earth. I use as many tools as I need to right now. I don't think some tools are available for me that used to be available for me, but it's only because I used them too much. Carpenter, masonry. I don't know much about either of those. Okay. Well, that is our show for tonight. Remember to listen to me instead of your weather app. Because I'm right, and your weather app is not a person with intuition. Not saying I have a lot of intuition, but I'm saying I have more than a computer. Listen to your experienced forecasters, not just me. Listen to like human being forecasters, because they're probably going to tell you what's right and wrong about your mechanical processed algorithm machine churned out numerical forecast. Relying solely on numerical guidance for forecasting is looked at as amateurish and unwise in the meteorological field. You have to use your context clues, your knowledge of previous events, and that little je ne sais quoi, that instinct, that intuition, if you want to be a good forecaster. So listen to forecasters that have just a little bit of a connection to the weather intuitively. I love you guys so much. I am so grateful I made it home to be able to do this forecast tonight. I love you all so very much. Please take care of yourself and those around you. Industrial arts, woodworking, and metalworking, automotive. That's really cool. I've always wanted to build my own biodiesel engine, but I have not learned enough yet in that field to do so. Yeah, I love you guys so much. I'll see you tomorrow. Have a great evening. Bye.